Today my guest is Seth Juarez.
How you doing?
How you doing?
Great.
How you guys doing? What do you do?
Well, I am with DevExpress. I'm a technical evangelist, and primarily I deal with how to present data statically through reports. And so anything having to do with data, I really just enjoy looking at. So one of the things I really like is looking at people's data and then thinking about how to lay it out on a page. That to me is interesting.
Oh wait, isn't data boring?
Well, I mean, you would think so, only because we think of data as like these massive, like Excel spreadsheets of just stuff, and the same thing with table. But once you start to squeeze meaning out of data, then it becomes exciting. Just like no one likes lemons, but everyone loves lemonade, right?
Interesting analogy. I briefly met you a year ago here at Codestock. You gave a talk that I missed. It was on machine learning.
It was.
And I was kicking myself because everybody was raving about the talk. It was the buzz of the cocktail parties afterwards.
Yes.
So I come back a year later and you're giving the same talk again. So I got to see it. It was really interesting.
Yeah.
And at the time you were actually studying, you were working on a PhD in,
That's right.
in machine learning?
Yeah, it was in computer science, specifically machine learning. See, Codestock was my first conference that I ever actually went to.
Uh-huh.
And so it was really neat to come and talk about machine learning to an audience that really, it's not that, I don't think machine learning is out of anyone's reach. It's just that no one really talks because they think of like robots and it's too complicated for me because I'm just an ordinary dev. I consider myself an ordinary dev. And so that the fact that I understand just a little bit of it means that others can too. And so I came here to give a talk. It was there that I met Gary Short, here that I met Gary Short, and then an evangelist position opened up and Gary told our boss, hey, get Seth. And I said, that'd be cool. I was studying at the University of Utah. I was a PhD student. My advisor unfortunately left. He got a better position at the University of Maryland, so I was left orphaned in Utah, and I decided, well, it's a good time to switch. So.
All right. When I think machine learning, I think the words artificial intelligence come to mind. Is that a fair comparison?
Absolutely.
Are they the same thing?
Yeah, it turns out that machine learning is a branch of artificial intelligence. When I think of pure AI, I think of like this glorified search problem that you need to somehow trim. And if you look at the first really big success in AI, it was Deep Blue when he beat Kasparov. And then the second great, I think, AI sort of feat was when Ken Jennings got beat by, what was the name of that? Watson.
Watson. Like 30 years in between those.
Yeah, but those two things were doing very different things. And so someone on Facebook posted, oh gosh, yeah, Watson won, who cares? Deep Blue. And I said, no, I don't think you really quite understand the difference. When you're playing chess, there's only a finite set, although a very large set of moves you can make, and moves that they can make, it's still finite. When you actually have the computer reading text, and let's face it, when you're watching Jeopardy, sometimes you're like, hey, the answer's blue, and then they're like, Lake Michigan. I didn't even understand the question, right? And so I'm the idiot that doesn't even understand the question. How is it that Watson can understand, I guess it's the answer, how does he know how to parse it? How does he know, it's just, I say the word he, obviously it's an it, but it's just an impressive thing, a set of things that you can do with AI, and machine learning is becoming sort of like the hot topic in AI, just because it sounds so scary.
Yeah. So machine learning, give me a quick definition.
So there are certain class of algorithms that you and I work on, and that you work on as well, that you start to have a lot of switch statements or if-else. So the example that I love to give is one that actually someone worked on after I left Codestock. They try to see if they could detect whether checks were upside down or not.
Okay.
And so if you think about it, that's a really easy problem if the check is always the same. But in most banks now you can pick from any check in the world, right? And so you can put your own picture on it almost. Right. And so the problem of detecting whether that check is upside down.
I have a picture of you on my check.
Oh, see, there you go. I should get one of you. Us together.
I'll send you one.
Cool. And so that's a problem. How do you actually make if-else statements for all the checks that could exist? You just simply can't. So the idea of us getting a problem and coming up with a certain set of steps to solve it becomes very difficult in that instance. So machine learning turns that upside down. Instead of us coming up with a series of steps, we give the machine a lot of examples of what we want it to do, what the right thing is to do, and let it figure out how to do it.
Okay, so it's recognizing patterns.
Yeah, in its basic essence, it's generalizing a problem by finding patterns.
You talk about unsupervised learning versus supervised.
Okay.
What's the distinction there?
So supervised learning is when you give it examples with the right answer.
Okay.
And what the hope is, in the end, once you have all this set of examples and right answers, if you give it a new example, the machine should be able to give you the right answer.
Okay,
Based
so
on the
as a
answer.
check example, you say, here's a bunch of checks, and I'll tell you which ones are upside down.
That's right.
Right side up.
Exactly. And so supervised learning is just an approach for being able to generalize a problem to get an answer. And you give it a lot of examples. So it's like learning with a teacher, where you give it examples and the right answer, the computer sort of just figures it out. Unsupervised learning is a little bit different. It's when you just have globs of data and you want to make sense of it. For example, for us, it's very difficult to look at, for example, 100,000 rows in a table and make sense of it.
Sure.
So if your boss says, I want you to look at all our customers and tell me stuff about them, well, what can I tell you? And so unsupervised learning is a way to look at your data and to be able to, and I'm going to say this, it's probably the first time I'm saying it like this, it's a way to compress your data in a way that you can understand it.
Okay.
And so either you group it, or you set up some kind of hierarchy structure, or you look at just the general statistics of the data. But in this case, there is no teacher, there's just data, which is the difference between supervised and unsupervised.
And computers are capable of both.
Yeah, and the cool thing about computers is that they don't get tired. So for example, us, if we have to go through manually look at data, as humans, we're just seriously going to get tired of looking at rows in Excel. The computer does not care. It will work all night, all week long, crunching stuff together, putting it in a form that we can understand. And so I guess I like the notion that unsupervised learning is more of a compression of your data to help you understand it better.
Okay. And then there's algorithms that have been developed and are still being developed.
That's right.
Tell me about some of these.
So one of the interesting ones, one of the first ones that I know about was invented in 1957 by a guy named Frank Rosenblatt. It's called the Perceptron algorithm. It's a very 50s-esque name.
Yeah, in fact, I'm going to say that now. Perceptron.
Perceptron, it sounds like some robot. And really what it does is, when it comes to, this is a supervised learning algorithm, when it comes to supervised learning, in essence, what you have to do is you have to be able to come up with a decision boundary. And what that means is imagine your data is a series of points. What you need to do is you need to be able to separate the points. So let's talk about binary classification, which is a form of supervised learning, which is whether it's deciding between a yes or a no kind of thing.
So a bunch of points, each point represents a yes or a no?
That's right.
Two states, all right.
And so imagine those points laid out, and imagine in your head you've seen a series of points. Imagine one set of points is red, one set of points is blue.
Okay.
You have to be able to separate those so that if you get a new point, you'll be able to say this is red or this is blue. That separation is called a decision boundary. And the easiest decision boundary is a line. So if you want to separate a series of points, you put a line between them, and if you're on this side, you're blue, if you're on this side, you're red. And so the Perceptron algorithm is a way to find a line that separates the data.
Okay, so this assumes that this data is going to be clustered. All the reds will be together and all the blues will be
Yeah,
together.
it assumes that,
along the X and Y axis that you chose.
it assumes that it's linearly separable. And what I mean by that is that you don't have, so if you can imagine like a grapefruit with a really thick skin,
Okay.
if you cut that in half and imagine the white of the skin on the outside being like the red points, or I guess the blue points, and the red in the middle being, there's no line that separates that. And so that becomes linearly inseparable. And so if your
That
data
algorithm would not work with that
no.
data set.
But you can cheat. There's ways to actually make things linearly separable, which is what some of the newer methods, like for example, support vector machines, use kernel methods to actually project your data out in a way that you can make it linearly separable.
I have no idea what you just said.
So imagine, okay, let's pretend you have a sheet, and you spilled a lot of something red. You spilled red paint in the middle. So there's this red splotch in the middle, and let's pretend those are your red points, and pretend that your sheet was white, and every point on the outside is white. Okay. So you have this sheet with this red circle in the middle. You want to be able to separate the reds from the whites. Notice there's no line, we said that already. But now imagine taking your sheet from the middle of the red and just pulling it up.
Okay.
Right, so now you have this like cone of red and then white, right? It's like this because you're pulling it up. Now notice that is separated by a plane, which is still linear. And what you do is you just hack off the red part, and now you have this plane in a new space that you've done that does separate it. And so now the words that I used were kernel and separable and stuff like that. What the kernel does is it moves your data like we just moved the sheet to make it so that it's linearly separable. So when I say lines, everyone's thinking like a line in three 3 space, it's a plane, 4 space, it's a cube, and 5 space, it's a hypercube. And so anything that's linear, so a plane is linear, a point is linear. And so when I pull the sheet up and I hack off the top, that is linear. And so we can still use linear models on stuff that is linearly inseparable if we project it into a new space.
It's that projection that makes that possible, okay.
Yeah, and so the sheet example is we went from 2D to 3D by pulling the middle up and this hack in. And so to me, that's the best way. That's called a polynomial kernel, but it's the best way to imagine how to take your data and massage it so that you can get a linear decision boundary. So Perceptron is just that. It's a linear decision maker. The kernel version of the Perceptron allows you to project it into a new space so that it becomes linearly separable.
Okay. You saw, I wrote it down here, another algorithm is the Kmeans. What is that an algorithm?
K-means is an algorithm. It's an unsupervised algorithm.
Okay.
So imagine having a link query and you want to separate your data. So your link query would be var q equals from p in persons.
Okay.
And you have a group by. Now, imagine not knowing what to group it by, but just saying group by, well, group it into 5 different things. So notice there's no criteria at all.
Okay.
And so what the Kmeans algorithm does is you give it a K, you say how many groups you want, and it says, say you have a list of 100 people, and you give it 2, what it's going to do is it's going to automatically group those people into 2 separate groups. And so the question arises, well, how do you do that? So the important thing in unsupervised learning is this notion of distance. How far away is one person from another person?
Okay.
And this becomes easier when we think about it as points x, y, in space. So how far away is x, y from this other x, y?
Okay, so you take all your data, you map it out in a scatter diagram in x, y space, all right?
And then what do you do?
You build a distance between every single point.
Yeah. And so what you do is that Kmeans algorithm is something called, it's a class of algorithms called EM, which is an expectation maximization algorithm. And what it does is it says, okay, let's guess where the K centers are. And then what we do is,
center is
so when you say you have, say you want to do 2 groups, each group is going to have a center.
okay.
And so what we do is we just guess what the centers are.
Okay.
And there's various forms of guessing. And then what you do is for each point, you assign it to a center.
Okay.
So say you have five points and you have 2 centers. So for each of the 5 points, you say, okay, point 1, are you closer to this center or are you closer to this center? Oh, I'm closer to this one. Okay, you belong to him. Point number 2, closer to this center or this center? Oh, okay, I'm closer to this center, I belong to her. And so you do that. So that's the assignment step. Then what you do is, since the guesses probably weren't right when you started,
Sure.
is you take all of the points on each team and you take the average and you move the centers to that average.
Okay.
Then what you do is you reassign. Okay, are you close? Yeah, and you do this until it stops. And then there's an animation.
Until the center stops moving.
Yeah, until the center stops moving. There's an animation that I do that shows you this process. And it was in fact this algorithm I wrote in MATLAB when I was in grad school at the beginning, that I watched it happen. And seriously, it was the most surprising thing for me to watch the computer group stuff, even though I knew exactly. And the algorithm that I just told you is very simple. It's just, centers. Pick teams, okay, move centers, okay, pick teams, okay, stop. We know exactly what it's doing, but it's surprising to see the computer thinking.
Right.
And so that I think is one of the coolest things.
Very cool. What are some practical applications of this?
That's a really good question. There are tons of them. In fact, the one that probably most people are aware of is something I didn't talk about. It's called collaborative filtering, wherein in Amazon, if you buy something, it always seems to know what to suggest to buy next, because it's in their best interest to move products.
Mm-hmm.
And so collaborative filtering is a way to use distance instead of between points, between people and products, to be able to suggest something. So let's say you and I buy this exact same kind of books.
Okay.
And what's your favorite book? What book have you just looked at?
Catch-22 by Joseph Heller.
Catch-22. So say I bought every book that you've bought.
Okay.
And so when it comes to distance, as far as books, our distance is very close because we have the same books. Now you buy Catch-22. What's the computer going to think? Well, since Seth is similar to Dave,
Then Seth also will do
Seth will also like Catch-22, right? And so notice that now we're looking at distance between people. And so since your distance is really close, since we're really close in distance, that means that all the stuff that you buy, I might also buy.
Okay.
Do you see that? And so it looks at that. It looks at, okay, let's look at similar people and then let's suggest products. The reverse is, let's look at similar products, and then look at the set of people that have bought that product.
Okay.
Do you see what I'm saying?
Sure, yeah.
And then, since this product is similar to this product, then this group of people will also want to buy this product. So notice that we've looked at a user, person-centric collaborative filtering
Sure.
versus product-centric collaborative filtering. And notice that that goes back to what we talked about as far as distance between points. There's a way to generalize. And so the library I built is called Machine Learning for .NET. It's on Codeplex. It's machine.codeplex.com. Look it up.
All right.
What it does is it allows you to take objects, like stuff we're used to, like person A and person B, and it projects it into vector space, which allows you to do the distance measurements.
Okay.
And so one of the next things I need to write is collaborative filtering, because everyone does that. I don't know why I haven't written that.
Collaborative filtering?
Yeah, that's the thing where you and I are close, and you
Okay.
bought Catch-22, so I must also want it.
Okay.
So it's a cool algorithm, and it's getting a lot. They use it everywhere.
Very nice. So I think you've done a really good job without any code or any graphics here. It's a tough thing to talk about
Yeah,
in this context, but I
it's a
have a better understanding of it.
it's a lot simpler than. So when you think of machine learning, you think of like Skynet and weirdness like that. And I'm serious, it's not that hard, but it's surprising how simple it is, and yet how it seems to be intelligent. It's not intelligent because it's only as good as the data you give it.
Where can people learn this? Where can they learn more?
So you can go look at my library. It's machine.codeplex.com, or literally type machine learning and into Google, and the Wikipedia entries are very good. There's tons of really cool algorithms that we should be using, and I'm trying to implement them so that we use them in the .NET space. Unfortunately, there's not a lot of .NET packages. There are a couple. I know Microsoft Research has one out, but you're not allowed to use it for commercial purposes. And so that's the unfortunate side, and it's really good actually. And
Maybe one of the control vendors will write a package.
Maybe we should.
Seth Juarez, thank you so much.
Great, thanks so much for having me. Hey friends, make sure you check out the machine learning technology on machine.codeplex.com. It should work. If it doesn't, help me out.